Okay, so hopefully that kind of got you a little, your teeth into it a little bit. Yeah, kind of see how it works. So we're going to kind of compare it to other things. So what are some advantages that Rust has over manual memory management? And that's C, C++. There's probably other ones, maybe Swift, but who knows? What are some of the advantages? Well, the big one, the big one is memory safety. Because the bane of every C and C++ programmer is memory unsafety, specifically probably segmentation faults. At least it was for me when I was programming C++. It was the worst because you didn't even know what was going on. It was terrible. Also, it leads to a ton of undefined behavior and security vulnerabilities, right? I have this on a tick point. Yeah, according to Microsoft, 70% of all the security bugs they have are memory safety issues. This is like published by Microsoft. That is,
for analysis 13.
Yeah. And if you are writing code in, now I have to say this, I have to say safe Rust. Well, I'm not probably going to get into that, but just know there is a part of Rust that you can do crazy shenanigans with. But if you're using safe Rust and you can do a million things in safe Rust, you cannot have memory safety or memory unsafety. Everything will be safe. You cannot access someone else's memory. You can't deallocate something and then use it again, right? Just doesn't happen.
Quick side note.
Yeah.
If someone else has a library and their library uses the unsafe keyword, do I then have to unsafe to use their library?
They choose on a case-by-case basis whether, like, so in Rust, to get anything, to ever access the heap in Rust, you have to, at some point, do unsafe. So the idea is somebody takes a lot of time and they very, very carefully write the unsafe part of Rust. And then they're like, all right, I made sure that everything here is correct. And then they wrap it in safe Rust. So then the only way to get into there is to go through their API. So so a vector, for example, right? A vector is an array, but it can grow. So that has to live on the heap, can't live on the stack. And so inherently that has to deal with memory. Inherently that could be unsafe. So the authors of Rust, or core team, whatever, or the core library, they wrote the unsafe parts. They were very, very careful about it. They did a very good job. They're pretty darn sure it's fine. And then they wrap it in safe Rust. So now you can use vector, the vector class struct, without needing to say you're doing unsafe things. If that wasn't the case, then every Rust program would be all unsafe, because you can't really do almost anything without at some point touching the heap, and you just can't do that safely. So, does that make sense? Enough? Yeah. Hopefully you'll have more background later when you learn more about Rust. Yeah. Cool. Tooling. Okay, so if you've ever tried to import a library into C, you will realize that there's no such thing as importing a library into C. That doesn't mean anything. You download code from SourceForge and then run CMake and make and something else, and hope that it all works, and it doesn't, and then you go with gnarly make errors, and it's super annoying. Rust has a tool called Cargo, which is a build system, right? So think actually, I don't even know enough build systems to say, but it also helps you bring in dependencies. So think like npm or Ruby gems or whatever, right? Adding a dependency to a Rust project is very, very easy. You just add a line to your dependency file. It's called cargo.toml, and then it will download it and build it, and it works pretty much every time. I've never had a problem with Cargo building a dependency. It's great, unless I program something wrong. The Rust C, so I kind of skipped Rust C. Rust C is the compiler, and once I've mentioned it before, amazing error messages, really helps you. It even we'll show this in a second, but if you do something wrong, it'll be like, hey, you couldn't do this because of this and that. If you want a more verbose explanation, run it again with this flag, and it'll actually get this whole page of explanation of why it's telling you what it's telling you, and why what you're doing is not possible, which is just amazing, right? Usually you have to go and find Stack Overflow, but this one just gives it in your terminal.
It even says did you mean to write it this way,
yeah,
example A, or did you mean to write it this way, example B? It's it could have corrected the code if only it knew what I wanted to do.
Yeah, no, and there's even sometimes where it's I know exactly what you wanted to do, but that's not allowed right now. If you just add this one thing, it'll be fine. And there's even a flag, and use this judiciously, but there's a flag, cargo build -- fix. And what that means is, hey, all those times where you knew what I meant to do and you were telling me exactly what to do? Just do it. Just go fix it. If you know so good, just fix it. It's okay, I will. I'll fix it. So that's amazing. I actually haven't used it very much. I'm a little bit scared of how powerful that sounds, but Sounds amazing. So,
Does it rewrite your file? Or?
yeah. It'll just go and like, it'll like, oh, you needed an ampersand here. Like, I know you needed an ampersand here. There's nothing else I could have meant. So you're like, cargo dash fix. It's like, all right, now there's an ampersand there.
Does that just use like Clippy or something?
Yeah, and like the Rust compiler, like.
That's literally a thing. Sorry.
Yeah. Yeah, there's Clippy is one of my next ones. Yeah, right there. Yeah. So Clippy is a linter. So the Rust compiler.
I wasn't making a joke.
Yeah. The Rust compiler by default has a bunch of like hints about like, hey, you probably needed an ampersand or a asterisk or whatever. But also Clippy is kind of the place where it's like, here's a bunch of things where it's like, not necessarily wrong all the time, but like this is kind of inefficient. You can do this better. Or like, hey, you called like filter and then map. There was a filter map or whatever, things like that, right? Really, really good. I run it on pretty much all my
I
projects.
was going to mention with cargo, you can actually specify the version of the dependency that you want to use.
Yeah.
So you can like say I want version 1.3.2 or
Yeah.
whatever, and it'll keep that version and compile that version of the dependency every time you compile your program.
Yep.
Using Semper.
Yeah.
I'm familiar with that, which is really nice.
Yeah. Then the one we skipped really quick, Rust format. Oh, sorry. Yeah.
That's actually, I was going to ask if there's a canonical way to say that.
Oh, I don't know. I know someone in this room always like
Just say Rust
crunch them
format.
together. So Rust format or something.
I always say Rust format.
Yeah.
Yeah, I usually say Rust format, but I'm losing precious syllables. So
In Go, everyone's favorite language, we call it funked. Like,
funked,
go
really
funked.
go.
That's why I call it
I feel
Rust
uncomfortable
Font.
saying that. I feel like I'm like.
Because I got Go.
Oh man, I just feel a little weird saying that. Okay. Okay. This is one thing. It's kind of random. It's technically built into cargo, but I put it as a different bullet. So I don't know if you ever run into this, but you run a documentation. So the best case is when you have a library and it has a bunch of documentation and it tells you exactly what to do, and you're like, wow, thank you. This is wonderful, and you go very fast. The worst case from that is when there's not very much documentation or any documentation. You're like, great, I don't really know how to use this. Guess I'm going to source dive. The worst case scenario is when there's documentation and it's wrong. And then you try it and then it doesn't do what you think it's done. That's just like the worst thing. So in Cargo or in Rust, you can actually have documentation that's marked as special like doc comments, and you can put code in them. And then when you run Cargo, before you publish it, or if you run your tests, like cargo test or whatever, right? It will actually take your comments that are your documentation, it will run them as code, and make sure all the assertions pass. Which means that your documentation will never be out of date, because if it was out of date, it would not compile, and it wouldn't let you publish it. That's just amazing. That's so cool. Like you know when you're looking in like crates.io, in Rust, a package is called a crate. The crates live on a website called crates.io, and you can go there and you look at the documentation, and you know that if you see something there and there's an assertion there that says like, assert foo equals 4, you know that's true, because if it didn't, it wouldn't have compiled, which is just great. I think that's
Just
so
a
cool.
quick note.
Yeah.
Cargo test runs all the tests and the doc.
Yes, yeah.
Cargo doc generates the docs.
Yes, yeah, sorry. This is kind of like the name of the tool-ish, but yeah, thank you for that clarification.
It actually generates a website.
Yeah, it's kind of cool. Kind of like Java docs if you ever did that. Kind of a similar thing. A couple other advantages. There's a lot of powerful abstractions. I know C++ has a ton of them. I just have a hard time using them. Maybe I'm just not good enough, and maybe it's because I haven't really done it since my third programming class in college. But Rust has a lot of really powerful abstractions. The trait system is super cool. There's no null. Okay, I cannot emphasize enough how great I think it is that there is no null in this language. It's just I deal with it way too much. And honestly, just the idea that you might have something and you might not is so common, and it's so easy to forget null in one place, right? Most of you will probably run into this. It's so obnoxious. So in Rust, you don't have null. You use an option. That's what this thing is right here. You can use an option, and that says, hey, you might have a string, but you might not, and you can't use it as you would use a string, right? You can't just go and print it out, put it where you'd put a string, because it says, hey, I'm not a string. I am an option of a string. If you want to get a string, you're going to have to look inside of me and handle the case when there's no string. So you can have a default string, or you can return early and say, I can't do it. Or maybe you return an option. Maybe you're like, all right, well, I'm going to take your string and I'm going to turn it into an int. But if you had no string, then I have no int. That's fine. And then you return that, right? Whatever you want. You can handle however you want, but you have to handle it. You're not just going to accidentally call length on your string and have it be null, right? So I think that's great. trait system, when you hear traits, basically think like interfaces, basically. It's a kind of a simplification. Cool Rust people will tell you how much cooler traits are than interfaces, and I can't really explain to you why. I tried once and I failed, so I'm not going to do it, but apparently they're cooler. I think of them as interfaces. So, but they're very easy to use, and you can like kind of do like combinations. So I guess that's one thing. So you can say like, oh, I require you to give me a type, and it has to implement this trait, and this trait. Like all three of them. You have to give me all of them. So that's kind of cool. So, all right. Oh yeah, and if any of you ever dabbled in functional programming, a little Haskell, a little whatever else, Scala, I think maybe, I don't remember. So functional Scala stuff, you could have almost all that stuff in Rust, which sounds weird, right? They're like, wait a second. I thought there was like two opposite ends of the spectrum. I thought there was like C and Haskell, and they were like as far away as you can be. We're like, no, actually, we can have like all the performance of C, but then still have filter and map and reduce. Get them with iterators, which I'm not going to cover, but they're super cool.
And they're lazily evaluated.
Yeah, and lazily evaluated, right? Lazy programming for the win. Okay. All right, so that was C and C++ land, and a lot of you guys probably don't write C and C++. A lot of you guys are like, well, I write JavaScript, or I write Java, or I write Python, or TypeScript, or whatever, right? What advantages do I have over that? Well, one, it is a lot faster, right? We've mentioned this before. It's super, super fast. And there's no garbage collection overhead. Also, because the compiler knows so much about your program, it can make a ton of optimizations for you. I mentioned this before. I guess I'm kind of a broken record, guys. Sorry. One thing that's kind of subtle, more data in a Rust program will live on a stack versus a heap, which is good for a few reasons. And one of the reasons is just because it's all right next to each other. And if you know anything about like caches and cache lookup times and cache validation, right? Things are faster when they're close together. And in Rust, a lot of things are close together. So that's cool. It takes a lot less memory. Apparently there was one study, and I did find the actual like paper. So if you trust these people that were at some university, Toronto or something, apparently what they did, a garbage collected language needed at least 5 times as much memory to perform as well as a language with manual memory management, right? And that's like, I'm pretty sure, if I understood correctly, I don't have a PhD, but that's like the bare minimum, right? You need at least 5 times as much memory. Usually it's going to be a ton more than that, right? Like Java needs like 200 megabytes to start up, and a lot of Rust programs run on like 15. So like even just starting up, it's going to be way faster.
So I do just want to point out that is mostly true, but there are tricks that you can do in
Yes.
selected languages that will make them not put things on the heap.
Yes.
You can't explicitly tell it, but you can
Coax it.
You can coach it into not putting things on the heap.
Yeah, it's true. Yeah, almost all these things are not like 100% all the time, and there's a lot of amazing the Java garbage collector is like amazing piece of engineering, does amazing stuff, and I'm grateful for it. But it is nice to like not use it when you don't need it, right? And that's actually kind of a theme of Rust that I didn't put on a slide, is that it's a pay for what you need language. So if you do need garbage collection, right? Like for example, if you are writing code that has a graph, right? Like a bunch of nodes, and they're all connected. We haven't talked about ownership quite yet, but that's essentially not how Rust works. Rust has like one person owns it, and he owns something else, right? You can't have him, which owns the first guy. That just doesn't work in Rust's model, unless you convince it to, and then and that does come at an extra cost, but it doesn't come until you ask for it. That's a great thing. Like if you will almost never have a time where you paid for something without realizing it. It'll make it explicit, which I'm a fan of.
That's similar to the unsafety model as well, right?
Mhm.
Like, you can be unsafe, but you gotta buy it first.
Yeah, you got to be at least willing to type in the words unsafe. And just for me, that kind of scares me, and I just don't want to like admit to myself that I'm doing something potentially unsafe, so I don't do it. So
You have to
yeah.
type unsafe to implement it yourself.
Yeah.
If, there's a number of things, like some of the fancy parallel programming
Mhm.
things like crossbeam have like a built-in garbage collection system to
Mhm.
make the block-free concurrency stuff
Yeah.
more efficient.
Mhm.
But that's all done with little unsafe blocks for critical areas of the code that they've carefully guarded.
Just kind of wrapped it
Yeah.
for you.
Yeah.
Yep. Yep.
But there are a number of things in the standard library that have unsafe under the covers.
It's a
But
lot of
they,
Yeah.
yeah, well, a lot of it, yeah. All the heap-related things, yeah,
Mhm.
certainly.
I just trust them a lot more than I trust myself. So
Yeah.
I'll use their stuff. Not going to go write my own vector. Yeah. Oh, and also if you're in a area where you need predictable performance, so like depending on who you're talking to, it might be a web server, right? Like you don't want like, I don't know, actually a lot of web servers are fine with this, but with garbage collected language, most garbage collected languages will have significant times where they're down. Some of them, like Go apparently has a really good one where it's like it's like never more than a few milliseconds, but a lot of them do like have like 150 milliseconds where they're down. And if you're running a web service, that can be a big deal. So yeah, and like airline avionics software, they just don't allow you to use garbage collection because they don't want the airplane not to respond fast when you're trying to turn it. So good
Kind
stuff.
of related to that, there was like a blog post that Discord made recently where they took Go basically to its limits, but it was still having to take about every 2 minutes, deallocate everything with the garbage collector. And when they were doing a lot of like mark as read or like seeing if messages were read by users, when you have billions of users, that adds up really quickly.
Mhm.
And so they were able to move it to Rust, and for that use case, Rust was a lot better for not having to deallocate the memory every 2 minutes. It just did it as needed throughout, and it kept the performance a lot better.
Yeah, at the very least, it's like it took something that was like pretty low, but then a lot of spikes, and they made it like slightly higher, but very constant. And that's kind of a theme of Rust, right? It's very stable performance.
It was even more interesting than that because they managed to make it so they actually weren't using any more memory. They were using a constant amount of memory, but it was hard-coded into the Go's runtime that every 2 minutes we're going to do a garbage collector sweep anyway. That's sort of like a max bound if we haven't encountered it yet.
Uh-huh.
And so like even though they had done everything right, they still had to battle the garbage collector and they lost.
Okay.
And anyone who
That
comes from
makes more
Java may
sense.
I wasn't
have
explaining it quite
hit
right.
similar situations.
It is worth noting though that with that blog post, they were using older version of the
Yeah.
Go garbage collector.
Yeah.
It goes great, don't get me wrong.
It was kind of funny. They're like, wait, so why are you using the like super old version of Go, but nightly Rust?
1.5?
That's kind of weird.
I don't know how old was it?
I don't know, they're on like
remember exactly.
114 right now, and it's like 1.9 is what they use.
Yeah.
Yeah.
So,
That is
yes, I'm pretty sure since 1.9, they've gotten the garbage collector
Yeah,
down
it
to
was like
below
110 or
1.07.
112 where they
Yeah.
added
Yes,
a
that was
better
the-
garbage collector.
The
so-
latest update was in that range.
I don't even use Go, but I just remember that from the
I use Go.
I-
I also use Rust.
Get out.
Yeah, we
Well,
love.
yeah, I'm here for using
No.
Rust.
Yeah, well, we've talked about that. So like, which one last thing, like if you're writing something that has to like do the memory management yourself, like if you're writing the operating system, you cannot use Go or Java or something, right? Like it needs somebody to provide it the memory allocation, right? If you want to be the memory allocator, you can't, right? So you can write that in C or C++ or Rust. I think are pretty much the options. So, great. Okay, and then so we're going for a little while, but one of the big advantages over pretty much every other language is this concept of ownership. And we mentioned before, so this lets you do fearless concurrency. And I will admit to you that I do not like writing multi-threaded code. I just like, I know the concepts, I took a class in college, I do know that, like the principles of like, mutexes and locking before you unlock and only accessing data after you've locked it, right? But I'm just so paranoid because I make so many mistakes. Like all the time, I write code with bugs in it. And I just know that I'm gonna write some crazy gnarly bug where I didn't quite do threading correctly and everything's gonna blow over my face. At least that's my fear. That's what keeps me up at night. And the great thing about Rust is that this is kind of one of their taglines. It's fearless concurrency. You can write multi-threaded code in Rust and you don't have to be afraid because if you messed up, the compiler didn't compile your code. And that's just crazy. Now you do that, it's not costless, it's fearless, it's not costless. The cost is that you do have to write your code in such a way that lets the compiler know you did it correctly, right? Like in most other languages, you access something and there's no compiler guarantee that you had the lock. In Rust there is, and which is crazy. But you do have to write your code correctly, and even more than that, you have to write like provably correctly, right? The Rust compiler essentially has to prove to itself that you did it right. And if you can't prove you did it right, then it doesn't compile. So that can be challenging. And honestly, it's not something I have a ton of experience in. Somebody else has done more concurrency stuff, they can chip in. But from what I understand, the cool thing is that if you don't do it right, it doesn't compile. So, and it has to do with this ownership thing.
Yeah, if
Yeah.
you're just doing, straightforward threads and mutexes and stuff, that's usually not the most efficient way, but it's really easy.
Mhm.
It's no harder in general than any other language that
Yeah.
you program in that way, as long as you do it correctly. If you start trying to write it the wrong way or saying, yeah, I don't really need to do that here, they'll say, no.
Like, no, you need it. Yep. Yeah.
And one thing just to clarify, here it says data races are prevented. Earlier you said race conditions.
Sorry.
This ladder is correct. This
Sorry,
ladder is
thank
correct
you.
right here. There are still some race conditions that you can still get, like if you have two mutexes, for instance, one thread grabs one thread grabs the other,
Yeah.
and then they try to grab the other's mutexes. That's the dining philosopher's problem, right?
Mm-hmm.
You're still going to have a deadlock there.
Yeah.
So that's a race condition you're not going to avoid. However, that's a heck of a lot easier to debug than why the crap is this variable randomly this value?
Mm-hmm.
Because I didn't synchronize access to a primitive that I'm using.
Yep. Yeah, thank you. I meant to go through and catch those, and I forgot. So thanks for catching that.
Does it also support another model of concurrency, like for example, message passing?
I believe
Yeah, RTF.
so. Yeah.
Does it-
Channels.
Yeah.
It does have channel.
Mhm.
Yeah,
Yeah.
channels.
They're not built in like in Go. Like there's no equivalent to the Go routine in
so it's
Rust.
in a library?
But yeah, but there are I think several libraries that provide things like
Yeah.
channels.
Well, no, channels are built in.
They're in the
Channels?
standard
Well, they're in the standard library. They're
There
not
is-
built into the language.
Oh, okay.
Right, right. Like Go routines are like, from what I understand of Go, they're like in the language.
And
Go
channels
routines and
are-
channels are separate things.
Yeah. Okay. Sorry.
So,
You're right.
Go routines are equivalent
Like-
to like futures.
Yeah. 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 Thank you. Thank you.
Kind of, sort of. Not really. That's a bad analogy.
Okay.
I hope I'm not stepping on your toes, but like with regards to currency, the new async await stuff is pretty awesome. And with parallelism, there's libraries and stuff that allow you to do things just like change your iterator to a par iterator.
Yeah, I
and
was gonna mention that,
It's parallel, and it's like for most things that's pretty cool.
Yeah.
So I've used that in a couple different spots. So anyway, I'm just throwing out there are some cool stuff that not mutexes and locks where you just but more like other types
High
of
level,
concurrency
easy to use.
with async await stuff where you just write normal code, quote unquote, you sprinkle asyncs and awaits
Yeah.
in the right spots,
So,
and it
It's,
shares this processor when it hits IO bounds and stuff like
Mhm.
that. But
it's one of these things where there's a trade-off. You're paying a little bit of complexity of having to choose which concurrency model you want to use and having to use the interface rather than having it built into the language. That's like the core way you do it. But the benefit is, if you don't need it, it's not built in
Mhm.
to the runtime. And you can pick different ones. If you want to do data parallel stuff for numeric processing, then you can do that. And if you want to do, lightweight, handle a billion connections at once with async things, you can do that. And you can choose to use threads or whatever.
I was just gonna clarify with async await, you do have to provide something that is basically a runtime.
Yeah.
So,
Mhm.
and then I'm just gonna leave it at that, but.
Yeah. Kind of like I mentioned before, it's kind of like a bring your own kind of saucy. If I mentioned that, I don't remember if it did. A lot of this Rust stuff, like you pay for what you need and kind of bring it yourself. And by bring yourself, I mean import someone else's library that did it for you. So, right, like if you want garbage collection, you bring in something to do reference counting, essentially, poor man's garbage collection. If you want async await, you bring in the async await runtime, stuff like that. Was there another hand, or did I get them all? Okay, cool. Yeah. Okay. Yeah. I forgot I clicked the next slide. It sounds like maybe small, but I think it's big. Even when you're not doing like multi-threaded, parallel, whatever, just the fact that you have explicit control over what's mutable and what's not and who owns it actually helps reduce a ton of errors. Like that's just a classic problem of like you hand somebody an object and later something else like a million miles away is changed. Just doesn't happen as much. Like I'm sure it could in the right scenario, but like it doesn't happen as much because you're very conscious the entire time you're programming Rust what's mutable and what's not, and kind of getting ahead of myself. But in a lot of languages, you can say like, oh, this is final or this is const. And that's great and all, except for Rust does it backwards. Everything is const, or everything is final, unless you explicitly say, okay, well, this one actually I'm going to change. But like that's like, oh, I have 17 variables and 2 of them are mutable, instead of I have 17 variables and I didn't write final on all of them, so they're all immutable and I don't know which ones are changing, right? So that's just a kind of a paradigm shift for me that I really enjoyed.
And I want to add on to that. One of the cool things about it is the beauty of Rust is it's all static analysis.
Yeah.
Like, you're basically getting garbage collection from the static compiler rather than a runtime, right? And
Yep.
with the mutability stuff, it's all just tagged for the static compiler. And so you declare another variable and you like if you think about the way const works, it's complicated in terms of the way that Rust works. Like Rust is so simple, you just copy a variable from one place to another. It's not actually going to copy the memory, but you're going to get a mutable reference to that variable.
Yeah, we'll talk about what that means.